Okay guys, so we now need to start relative, 1D relative, okay? 1D relative in our kinematics. 1D relative. So, you just need to, realize this thing first. What is 1D relative? What is the relative motion actually? In that case, if I say there is one body, it is moving with the velocity of 10. Say for example, okay? There is another body which is moving with a velocity of 20, and there is one body which is the ground frame, not moving, 0, not moving. So if I say, so we shall name them A, B, and this one is observer O. So what is the velocity of A with respect to observer? You would say 10. Okay, and if I say it's moving in the horizontal x-axis, 10 I cap, you can say that 10 I cap. What is the velocity of B with respect to the O? Now you would say 20 I cap meter per second. And if I ask the velocity of A with respect to the B, you are now in the frame of A. Now in the frame of A. So what will the velocity? Velocity of A with respect to the B. Okay, velocity of A with respect to the B. So you are in the frame of B. Okay, the letter which comes later, you are in that frame. So velocity of A with respect to the B is like you are in the frame of the B. So what it would be? 10 minus 20. Okay, minus 10 I meter per second. So that's mean if you are in the frame of B, you would see A going backwards. Imagine you are in the B. How would A look like? A would look like it's going backward. Okay, so let's and if I ask you various things, in the same, what is the velocity of B with respect to the A? So velocity of B minus velocity of A. So what was the velocity of B? 20 minus 10, so 10 meter per second. Okay, and whatever we ask, okay, it would look like from the frame of A, it would look like B is going with the velocity of 10 meter per second. If you sit on B, it would look like A is going backwards, and if you're in the frame of A, it would look like B is going just a second. It is look like B is going forward. Okay. Now okay then. So, and if I ask you what is the velocity of, just give me a second. What is the velocity of B with respect to the ground frame? It is 20. What is the velocity of A with respect to the ground frame? It is 10. Okay. If I ask you what is the velocity of the person at the ground with respect to the B, it will be minus 20. Velocity of the person at the ground with respect to the A or ground, it is minus 10. You get what I'm trying to say? Okay. Now see, if I ask you is these things like this way, tell me, just one second. Just give me a second. When I ask you things like this, there is one body and there is another body. Okay, what should I name this body? Just for the aesthetic purpose, I also use. So this is one body, this is another body, and let's name it A and let's name it B. Now they are moving towards each other. This is moving with the velocity of 20, this is moving with the velocity of 30. Now if I say what is the velocity of A with respect to the B and what is the velocity of B with respect to A. So the only thing you need to remember is that is VB minus VA only. And what is VB? Negative 30. What is VA? Positive, but here is minus, so positive 20, so minus 50. From the frame of A, B would look like it's coming westward with a velocity of 50. And if I talk of VAVB, I get the same thing. VA minus VB from the frame of B. VA is 20, VB is negative 30, so it would look like positive 50 meter per second. Okay, so this is the velocity, relative velocity. Now better is if you do some problems over it. So I'll solve some problems, we'll deal with some problems. So there is one problem. Okay, so let's see, there's a car and I draw a car. Okay, it is at rest, but acceleration is 2 meter per second square. This is the acceleration. And then there is another car. Okay, another cart. It is moving with a velocity of 10 meter per second and acceleration is 1 meter per second square. Okay, so this is the case. I'll just make it easy for you. So if I ask you one thing, the distance between them is 100 meters. Okay, so my question is, would car can catch the cart, and if yes, then the time when it will be able to catch the cart. Okay, time to catch the cart I need to find, or whether it is possible. It is possible. We need to take care of that as well, whether it is possible. So let's solve it. Okay, now see, if I say what is the velocity of car, let's come in the frame of the cart. What is the velocity of car from the frame of the cart? Okay, it is a velocity of car, that is 0, minus velocity of cart, it is 10, so minus 10 meter per second. And it is obvious, from the frame of the cart, car would look like going backwards. But what is the acceleration of car from the frame of the cart? Acceleration of car, that is 2, and acceleration of car, that is 1, so it would be 1 meter per second square. But acceleration is 1. Now I'll show you what is actually happening here. Okay, in the next diagram. So the thing which is actually happening here is this. From the frame of the cart, what it would look like, that now you come in the frame of cart is at rest. Now it look like the car velocity is, I think, negative 10, but acceleration is 1 meter per second square, positive 1 meter per second square. So car would look like to go like in this way. It would goes backward then take a turn, and then come back for the cart. So problem here is 100 meter was the distance between them. 100 meter was the distance between them. So acceleration is this. So when it would be able to catch the cart. But can you see that it would be able to catch the cart for sure? Of course it would be able to catch the cart for sure. You just need to cross 100 meter. No? So the cart is at rest. It is having acceleration in the positive direction, for eastward, and the initial velocity was -10. So whatever would be the case, it would be able to catch the cart. First of all, this is possible. Now let's find what is the displacement when it catches the cart. 100. So S is 100. Acceleration is 1 meter. So I just use that equation, second equation of motion. ut, u is negative, t is t plus half into 1 and t square, and you just need to solve it and nothing else. So t square minus 20t minus 200. So whatever the solution of this, I think 10, whatever it is, so you use a quadratic equation, just do solve it and you will get the answer. Okay, so this is the answer from this. Now let's solve another problem of same likewise. Okay, in the next problem I'll give you acceleration of both things and would ask you to think over it. Okay, so let's solve the second problem. Exactly same. I would use the same problem. Exact same. There is one body and then there is another body. Okay, and I must say the acceleration of this is 2 meter per second square, and it is moving with the velocity of 30 meter per second. 30 meter per second. And for this, the acceleration is 4 meter per second square, and it is moving with a velocity of okay, 30 is not a right. I must say 10 meter per second. Okay, so again, when it would be able to catch it, or whether it is possible to catch it, or if yes, then find the time. So you need to find whether it is possible to catch. Of course, the back one, possible to catch B by A. And second is find the time when it will be able to catch. Time is starting from this moment. Okay. Okay. So find the time as well. So if I need to find if I come in the frame of this one, B. Let's come into the frame of B. Let's sit in the frame of B. So what is the velocity of A with respect to the B? Velocity A with 30 minus 10. So that is positive 20 meter per second. What is the acceleration of A with respect to the B? Acceleration of A minus acceleration of B, that is minus 2 meter per second square. Now, if you look in this situation, how does the situation would look like? I'll tell you. It would look like, for just give me a second. Just give me a second. So for B, it would look like that A is having a velocity in this direction. What was the velocity? I think it's 20. A is moving the velocity of 20 meter per second. A, but the acceleration is, I think, -2. Okay, -2 meter per second. And negative means opposite to the direction of the velocity. So whether